Today we will discuss the concept of coplanarity of two lines. So the first question is, what are coplanar lines? So lines which lie on the same plane are known as coplanar lines. So here we have a plane and two lines L1 and L2 whose vector equations are given here are coplanar. It means the two lines L1 and L2, they lie on the same plane here, right? Now the vector equation of the first line is vector r is equal to vector a1 plus lambda times vector b1. Then we have line L2 is vector r equal to vector a2 plus mu times vector b2. Now here line L1 passes through the point A1, or the position vector of the point A is vector A1, and the position vector of point B is vector A2. Now this line L1 is parallel to this vector B1 and L2 is parallel to the vector B2, right? Now here if we find the vector AB, then this can be written as vector OB minus vector OA, and OB is vector A2 and OA is vector A1, right? So this is our vector AB. Now the given lines are coplanar if and only if this vector AB is perpendicular to vector B1 cross vector B2, right? So here B1 cross B2 is perpendicular to the plane containing B1 and B2, because by definition of cross product of two vectors, we know that B1 cross B2 vector is perpendicular to, see, this is perpendicular to the plane containing B1 and B2. So therefore this is the B1 cross B2, and this B1 cross B2 vector is perpendicular to vector AB. So therefore the dot product of vector AB and this vector B1 cross B2 should be equal to 0, because the angle theta is 90 degrees, this is 90 degrees, and cos 90 degree is equal to 0, right? So vector AB dot B1 cross B2 is equal to 0, or in other words we can say that vector A2 minus vector A1 dot B1 cross B2 is equal to 0. So this is the condition for two lines to be coplanar, right? Now we know that the shortest distance between two non-intersecting lines, that is two non-coplanar lines, or in other words the shortest distance between two skew lines, is given by this formula. And here we see that if this expression is 0, and if we substitute the value of this expression as 0 here, we get the shortest distance 0, right? So if two lines are coplanar, then the shortest distance between the lines is 0, right? Now the Cartesian equivalent of this condition is this. Here the determinant is 0. This determinant should be 0 if these two lines are coplanar. So here x1, y1, z1 are the coordinates of this point A. The point A has coordinates x1, y1, z1, and the point B has coordinates x2, y2, z2, and a1, b1, c1 are the direction ratios of this line L1, and a2, b2, c2 are the direction ratios of this line L2, right? So a1, b1, c1 are the DRs of the line L1, and a2, b2, c2 are the DRs of the line L2, right? So this is the Cartesian equivalent of this condition. So whenever this determinant is 0, then the two lines are said to be coplanar. Now viewers, let us take this problem. Here we have to show that these two lines are coplanar. So this is line L1, this is line L2, and we know that the condition for coplanarity of two lines is given by x2 minus x1, z2 minus z1. Here we have y2 minus y1, then we have z2 minus z1. Here we have a1, b1, c1, a2, b2, c2, right? And this determinant should be equal to 0. Now we have to find the value of this determinant. If this determinant is 0, then the two lines are said to be coplanar. Now comparing this equation with this form and comparing this equation with this form, we see that x2 minus x1, what is x2? x2 is minus 1, and what is x1? x1 is minus 3, and then we have y2 minus y1, this is 2 minus 1, and z2 minus z1, that is 5 minus 5, right? And a1, b1, c1 is minus 3, 1, 5, and here we have a2, b2, c2 as minus 1, 2, and 5, right? Now we have to evaluate this determinant. This is plus 3, 3 minus 1, that is 2. Here we have 1, here we have 0, here we have minus 3, 1, 5, and minus 1, 2, and 5, right? Now if we evaluate this determinant, we have 2, here we have 5 minus 10, then we have minus 1, we have minus 15, plus 5, and then 0. And this can be written as minus 10, and this is minus 10, and here we have minus 1, so this is plus 10. And here we have 0, so this is equal to 0. So therefore the value of this determinant is 0 for these two lines. So hence we can say that these two lines are coplanar. If the determinant is not equal to 0, then the two lines are not coplanar. Clear? Now let us consider this problem. Find the value of lambda if these two lines are coplanar. So again, the condition for coplanarity is given by this determinant equal to 0, and here we have x2 minus x1. See, this is x2, this is x1, so we have 10 minus 3, y2 minus y1 is 2 minus 1, and then z2 minus z1 is 15 minus 5, right? And a1, b1, c1 is minus 3, here we have 1, here we have 5, and for a2, b2, c2 we have minus 1, 2 lambda, and 5, and this determinant should be equal to 0 because we are given that these two lines are coplanar, right? So we have compared this equation with this standard form, and again we have compared this equation with this standard form, and we have obtained the value of x1, y1, z1, x2, y2, z, z2, a1, b1, c1, and a2, b2, c2, right? And substituting that values in this determinant, right? Now this determinant is equal to 7. Here we have 7, here we have 1, then we have 10, and minus 3, 1, 5. Here we have minus 1, 2 lambda, and here we have 5. That is equal to 0. Now expanding this determinant, we have 7 times 5 minus 10 lambda, then we have minus 1, and we have minus 15 plus 5, and then we have plus 10, and we have minus 6 lambda, plus 1, right, equal to 0. So if we simplify this expression, we get 35 minus 70 lambda plus 15 minus 5, then we have minus 60 lambda and plus 10, right, equal to 0. So this is so simplifying this expression, we have 55 minus 130 lambda. This is equal to 55 is equal to 130 lambda, and lambda is equal to 55 divided by 130, and this is 5 11s are, and 5 2s are 10, and 3 5 6 are. So the required value of lambda is 11 by 26, for which these two lines are coplanar.